Welcome to another video for Algebra 1. We're solving linear systems by substitution. So just as a reminder, in the previous videos where we were solving linear systems by changing each equation into its linear form or its slope-intercept form, we solved each equation for a slope-intercept, and then we would graph those equations and see where they intersected. And that point of intersection, that single coordinate point, was considered to be the solution for each of those equations. Well, again, we're going to be dealing with substitution method in this video. So the first thing that we want to do as we consider our equations, we have two equations that will be given. I want to consider which equation would be the easiest to solve for a single variable. Okay, so which would require the least amount of algebra to isolate a variable. And really either one of these would work fine because I have y on the top equation that's been singled out, and then I have x on the bottom that's been singled out. So I'm going to go ahead and just pick the bottom one. Like I said, either one would work. It would only require one single step in isolating the variable. So I'm going to isolate this variable x. Okay, so I'm going to ignore my other equation for now. I'll come back to it later. And I want to just focus on this one and isolate x. I want to find the value of x. Okay. So then my first step algebraically would be to subtract 2y, and whatever I do to one side of the equation I must do to the other. So then that eliminates my 2y on the left side, and it gives me 2y minus 5 on the right. So I'm cleaning up my equation now. And now I have the value of x. Okay, I have my value for x, which is negative 2y minus 5. So now that I have the value for x, I can look to my second equation and look at the x on the negative 3x. I know what the value of that x is now, and I can substitute. I can substitute the x for the negative 2y over 5. Okay, so negative 3 times x is actually negative 3 times negative 2y minus 5. Now you'll notice also that by eliminating my x, I have now reduced my equation from two variables to one variable, which is what I want. So I'm going to distribute. Negative 3 times negative 2y is negative 6, or positive 6y, and then negative 3 times negative 5 is plus 15. We're going to clean up our equation now and keep doing our algebra. So we have our like terms to add. So that gives me a 7y plus 15. Cleaning up my equation a little bit, I want to get rid of my 15. So I subtract by 15 to both sides, which gives me 7y and negative 7 on the other end. So I'm almost done. So now I'm dividing by 7 to both sides to give me y and negative 1. So now I have the value for my y coordinate, which is negative 1. So I know now where my solution will lie for the y. But I still need to find my x, so I'm going to substitute my value for y, which is negative 1. Okay, so now I can do my algebra. Negative 2 times negative 1 is positive 2. 2 minus 5 is negative 3, and now I have the value for x. So I now have my coordinate. It's negative 3, negative 1. This particular coordinate, okay, so here's my two equations and my coordinate point. I'm going to graph this. So it's negative 3 and then negative 1. Here's my point. So this particular point represents the one point that both of these equations have in common. This is the solution to my system of equations, and I don't even need to graph my lines. You'll notice I don't know what my lines look like. I have no idea because I did not change them into my slope-intercept form. And in this case it doesn't matter because all I'm looking for is the solution. So again, this is substitution. This is substitution for linear equations. Okay, linear systems by substitution. Alright, so here's a quick rundown of what we just did. Distributive property, did the algebra to isolate my y, get the value for y, replace the value for y and x, find my x, plot my point, and there's my solution. Okay, hope this helped. Good luck in your studying.